QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. What if our quadratic equation has a coefficient greater than 1? Is this still factorable? Yes or no? The answer is yes. This is still factorable. Then what are the factors of the given trinomial? The factors are 2x plus 1 and x minus 3. What are now the roots of this given quadratic equation? The correct answer is -1/2 and 3. Did you get 3 over 3? If not, please continue viewing this video. Our quadratic trinomial here has a coefficient no longer equal to 1. Actually, it's 2, right? Because if we're going to have our coefficients, we have here 2 for A. That's 2. Pardon. That's 2. Oh. Again, that's 2. Our B is -5. And our C is -3. This is a complete quadratic trinomial, and that we are no longer allowed, or we are sure that we cannot use the extracting square roots and common number factoring for the process and solving the roots of this given quadratic trinomial equation. What we could use here, aside from the quadratic formula, is either the factoring and the completing the square method. And we could know that again, the factoring here is not the common number factoring, because the common number factoring is specifically for expressions without C coefficient, because it's easier for us to do that. Again, we have a complete quadratic trinomial here, and we know that we can use factoring if this is factorable, and if it's not, let us use the completing the square method. So we could start here by solving for AC as the process on determining whether this is factorable or not. Again, we are not yet allowed to use quadratic formula here, so we will dig deeper on those 2 steps. So AC here means 2 times -3 as A and C coefficients, which will result to -6. Now we're going to look for pairs of numbers that when multiplied, we will get -6. So we can start with 1 and -6. You could also have -1 and +6. Okay? We could also have 2 and -3. We could also have -2 and 3. These are the 4 pairs of factors that when multiplied to their corresponding partner will get -6, and when added will Now we are going to look for which of these 4, when added to each other, will result to our B coefficient here. Our B coefficient is -5. So which is which? Looking closely, again, this is not, that is incorrect. The answer is this one here. We have 1 and -6. 1 times -6 is -6. 1 plus -6, -5. Since we have located a certain pair, this is now factorable. We are sure of it, and we can use here factoring in solving the roots. But there is one also important thing that you need to be reminded of whenever you use the factoring for a quadratic trinomial with the a coefficient no longer 1. Before, we are actually using x and x here because x times x, x squared. But since it's 2x squared and 2 is not a perfect square, one of the two must be 2x. So let's use here 2x. We have two binomial expressions and we have here x. To satisfy the first product using the FOIL method, 2x times x, 2x squared. Okay? And then we're going to place now these two. But since these two coefficients, somewhere here and here. But since here comes the problem. Okay? We cannot just simply say plus 1 here and we have here minus 6. Because if we're going to use the FOIL method, even looking at the last terms, 1 times negative 6, it's not negative 3, right? It's negative 6. So there's something wrong in the process if we're going to push that further. Here's my suggestion. Okay? Here is my suggestion to you. Again, I understand this is not possible. 2x and 2x. But of course, 2x times 2x, it's 4x squared, not 2x squared. But in the meantime, let's just use 2x and 2x. Don't worry, one of which will be reduced later. And then after that, you can just simply and more comfortably place here your two coefficients. We have 1 and negative 6, the pair that we decided earlier. Of course, again, when we multiply this using FOIL method, we will not return to the original expression. What we can do here is this. Look at this term here. We can divide both terms by 2. And as therefore, we have here, this is still 2x plus 1. Why do we divide by 2? We actually reduce it in its simplest form. Because if we're going to have it like this and multiply the two factors, we will get a version of the quadratic trinomial, which is a multiple of 2. Okay? So we remove that 2 because that is actually our concern earlier, one of which is 2x and the other should only be x. But we use 2x on both so that we can comfortably place the coefficients that we have decided earlier. But either way, this is just x and 6 divided by 2 is minus 3. If you would like to check this, 2x times x, 2x squared. 1 times x is x. 2x times 3, we have negative 6x. X minus 6x, we'll have minus 5x, which meets the criteria for your second term. And 1 times negative 3 is negative 3. This is now your correct factors. Equate it to 0 because our goal here are not just the factors, but more specifically the roots. And we are going to apply here the zero factor property or the zero product property, which tells us that this situation is only true if one or both factors is equal to 0. So we equate both of them to 0 and we'll have this here. 2x is equal to negative 1. Divide x both sides. Your first root is negative 1 half. As one of our results earlier. Your second root is just simply positive 3. That's your second root. Okay? So, as a short summary, again, we started with identifying whether this is a factorable or not using the AC way. The decision as to whether this is factorable or not is when we locate a pair of coefficients that will result when multiplied to your AC and when added to your B. If there's no pair here, then we cannot use factoring. We might have an example for that later. Now that we are sure it's factorable, we use factoring here so that we could actually use the coefficients decided. Don't worry about the 2x and 2x there because one of which will be simplified. Now, there's a question. What if this is 3? So we will divide 3, not 2. But we divide it into 2 so make sure that our term here is x so that when we multiply 2x and x, 2x squared, we return to our original. And this is now, or these are now, the roots, negative 1 half and 3 or vice versa. This is what happens actually if your a coefficient of your quadratic trinomial is no longer 1. There is a little bit tweak on the process, but basically we follow the same concepts, we follow the same concern. in factoring for this QuadQuiz. Subscribe now!